Azure Vnet Remote Gateway Configuration. Welcome to this comprehensive presentation on Azure Virtual Network Peering with Remote Gateway Configuration. Today we'll explore a powerful Azure networking feature that allows VNets without VPN gateways to route traffic through the gateway of a peered VNet. This is particularly useful for hub and spoke architectures where you want to centralize your gateway infrastructure while still providing connectivity to multiple spoke networks. We'll cover the technical concepts, configuration steps, and provide detailed Azure CLI commands. By the end of this session, you'll understand how to implement this architecture and troubleshoot common issues. Understanding VNet peering fundamentals. Before diving into remote gateways, let's establish the foundation. VNet peering creates a seamless connection between two virtual networks, allowing resources in either network to communicate directly. Think of it like building a bridge between two cities. Once connected, traffic can flow freely between them. The key benefit is that this connection uses Microsoft's backbone network, ensuring high bandwidth and low latency. There are two types of peering: within the same region, VNet peering, and across regions, global VNet peering. Both support the remote gateway feature we'll be discussing. The magic happens when we configure specific peering settings that allow one VNet to use another VNet's gateway for external connectivity. The remote gateway architecture. Now let's visualize how remote gateway configuration works. In this diagram, we see a typical hub and spoke topology. The hub VNet contains a VPN gateway that provides connectivity to on-premises networks or other cloud environments. The spoke VNet doesn't have its own gateway. Instead, it's configured to use the hub VNet's gateway as a remote gateway. This is cost-effective because you only need one gateway instead of multiple gateways per VNet. Notice the peering connection between the VNets. This isn't just a simple peering. It has special properties configured. The hub VNet must allow gateway transit, while the spoke VNet must be configured to use remote gateways. When a virtual machine in the spoke VNet needs to reach on-premises resources, the traffic flows through the hub VNet's gateway, even though the virtual machine doesn't reside in the hub VNet. Key configuration properties. The success of remote gateway configuration depends on two critical peering properties working in tandem. Let me explain each one and why they're essential. First, allow gateway transit must be enabled on the hub VNet side. This tells Azure, hey, I'm willing to let other peered VNets use my gateway for their traffic. Without this, the spoke VNets can't leverage the hub's gateway infrastructure. Second, use remote gateways must be enabled on the spoke VNet side. This is like saying, I don't have my own gateway, but I want to use my peer's gateway for external connectivity. These properties are mutually exclusive with having a local gateway. You cannot use remote gateways enabled if your VNet already has its own VPN gateway. Azure will reject this configuration. This design enforces a clean separation between hub and spoke roles in your network architecture. Creating the hub VNet with gateway. Let's start building our solution step by step. First, we'll create the hub VNet that will house our VPN gateway. I'm using specific CIDR blocks that don't overlap. This is crucial for successful peering. The hub VNet gets a 10.0.0.0/16 address space, which provides plenty of room for subnets. Notice I'm creating this in the East US region, but you can adjust based on your requirements. The resource group, hub spoke RG, will contain all our resources, making management easier. Always use consistent naming conventions in your Azure deployments. It pays dividends later when you're troubleshooting or managing resources. This command creates the foundation VNet, but we'll need to add subnets next, including the special gateway subnet that's required for VPN gateways. Adding subnets to hub VNet. Now we are adding the essential subnets to our hub VNet. The first subnet is for regular resources like virtual machines. I am calling it Hub Subnet, with a /24 address space. The second subnet is special, the gateway subnet. This name is not arbitrary. Azure requires this exact name for VPN gateway deployments. The /27 provides enough IP addresses for the gateway infrastructure. When planning your gateway subnet, consider that Azure reserves the first 3 IP addresses and the last IP address in any subnet. Also, if you plan to use ExpressRoute alongside VPN, you might need a larger subnet. The gateway subnet should be at least /29, but /27 or larger is recommended for production environments. This gives you room for gateway scalability and coexistence scenarios. Creating the Spoke Vnet. Next, we create our Spoke Vnet, using a completely different address space, 10.1.0.0/16. This non-overlapping address space is critical, because Azure won't allow you to peer VNets with overlapping IP ranges. I'm placing this in the same region as the Hub Vnet. This makes it a standard VNet peering rather than global VNet peering. Same region peering has higher bandwidth limits and lower latency. The Spoke Vnet will contain workloads that need access to on-premises resources, but we won't create a VPN gateway here. Instead, we'll configure it to use the Hub Vnet's gateway. This approach is cost-effective and simplifies management, since you have fewer gateways to maintain and monitor. Adding Spoke Subnet. The Spoke Vnet gets a single subnet for now, the Spoke Subnet, with a /24 address space. This provides 251 usable IP addresses for your workloads. Notice we are not creating a gateway subnet here. That is intentional. The whole point of this architecture is that the Spoke Vnet will use the Hub Vnet's gateway instead of having its own. If you later decide you need a local gateway in the Spoke Vnet, you would have to disable the Use Remote Gateways setting first, then add a gateway subnet and deploy your gateway. This subnet will host your application virtual machines, databases, or other resources that need connectivity back to your on-premises environment. Creating the public IP for VPN gateway. Every VPN gateway needs a public IP address for external connectivity. This command creates a static public IP with the standard SKU, which is required for VPN gateways. The allocation method is static, meaning this IP address won't change even if we stop and start the gateway. This is important for maintaining VPN connections with on-premises devices that need to know the gateway's IP address. I am using Hub VPN PIP as the name. Clear naming helps when you have multiple public IPs in your environment. The standard SKU provides better SLA and security features compared to the basic SKU. This public IP will be associated with the VPN gateway when we create it in the next step. Deploying the VPN gateway. Here is where we create the actual VPN gateway in the Hub Vnet. This is a significant step, because VPN gateways can take 20 to 45 minutes to deploy. So, grab a coffee. I am using the VPN GW1 SKU, which provides up to 650 megabits per second aggregate throughput and supports up to 30 site-to-site connections. The gateway type is VPN, and we are using route-based VPN, which is the most flexible option. The gateway gets deployed into the gateway subnet we created earlier, and it automatically receives the public IP we just created. The "no wait" parameter lets the command return immediately, instead of waiting for the deployment to complete. While this deploys, let us continue with creating our peering connections, which we can do in parallel. Creating hub to spoke peering. Now we create the peering connection from hub to spoke. This is half of the bidirectional peering relationship. The key parameter here is allow gateway transit, set to true. This setting tells Azure that the Hub Vnet is willing to let peered VNets use its VPN gateway for external connectivity. Without this setting, the Spoke Vnet couldn't leverage the Hub's gateway. The peering is created within the Hub Vnet and points to the Spoke Vnet's resource ID. Make sure you use the correct resource ID. A typo here will cause the peering creation to fail. Notice we're not setting use remote gateways on this side. That would be inappropriate since this VNet has its own gateway. That parameter goes on the other side of the peering. Creating spoke-to-hub peering. This is the other half of our peering relationship. We're creating the peering from spoke to hub, and here's where the magic happens with the use remote gateways parameter set to true. This tells Azure that the spoke VNet wants to use the hub VNet's gateway for external connectivity. The spoke VNet is essentially saying, I don't have my own gateway, but I want to route external traffic through my peer's gateway. This command will fail if the hub VNet doesn't have a gateway or if the hub-to-spoke peering doesn't have allow gateway transit enabled. The two peering configurations must be compatible. Once both peerings are established, virtual machines in the spoke VNet will be able to reach on-premises networks through the hub VNet's VPN gateway. Traffic flow analysis. Let's analyze how traffic actually flows in this configuration. When a virtual machine in the spoke VNet needs to reach an on-premises resource, several things happen automatically. First, the virtual machine's routing table is automatically updated by Azure to include routes for on-premises networks, learned through the hub VNet's VPN gateway. This happens because of the use remote gateways setting. When the virtual machine sends traffic destined for on-premises, it flows across the VNet peering connection to the hub VNet. From there, the hub VNet's VPN gateway handles the traffic and sends it over the VPN tunnel to on-premises. Return traffic follows the reverse path, from on-premises through the VPN tunnel to the hub VNet, then across the peering to the spoke VNet. This is completely transparent to the applications running in the spoke VNet. Verifying your configuration. After deployment, it is crucial to verify that everything is working correctly. These commands help you check the status of your peering connections and gateway. The first command shows the peering status. You should see connected for both peerings. If you see initiated or disconnected, there is a configuration issue to resolve. The second command checks your VPN gateway status. During initial deployment, you might see updating status. Wait for it to reach succeeded before testing connectivity. The gateway show command also reveals important information like the public IP address and the gateway SKU. You will need the public IP when configuring your on-premises VPN device. Always verify your configuration before moving to production. It is much easier to fix issues early in the deployment process. Important limitations and considerations. While remote gateway configuration is powerful, there are important limitations you need to understand. These aren't bugs. They're architectural design decisions by Microsoft. First, a VNet can only use remote gateways from one peer at a time. You can't have multiple peering connections with use remote gateways enabled. Azure will prevent this configuration. Second, you cannot have a local gateway and use remote gateways simultaneously. It's one or the other, never both. This enforces the hub and spoke model clearly. Third, the VNet providing gateway transit can be peered to multiple spokes, but each spoke can only use one hub's gateway. This creates a star topology, not a mesh. Understanding these limitations helps you design your network architecture correctly from the start. Let's discuss the most common issues you'll encounter and how to resolve them. These problems account for about 80% of the support cases I see with remote gateway configurations. The first issue is peering status stuck in initiated. This usually means the peering properties are incompatible. Check that the hub VNet has allow gateway transit enabled and that there is actually a gateway deployed. The second issue is connectivity working within Azure but not to on-premises. This often indicates that the VPN connection itself isn't established properly, or that on-premises routing doesn't know about the spoke VNet's address space. The third issue is subnet routing problems. If virtual machines can't reach each other across peered VNets, check for NSGs blocking traffic or UDRs interfering with the default routing. Always check these basics first before diving into complex network troubleshooting. Best practices and recommendations. Based on years of implementing these architectures, here are my top recommendations for success. Following these practices will save you time and prevent common pitfalls. First, always plan your IP address spaces carefully before deployment. Overlapping subnets will prevent peering, and changing them later requires rebuilding resources. Use RFC 1918 addresses and document your allocation strategy. Second, use consistent naming conventions. When you have multiple VNets, peerings, and gateways, clear naming helps with management and troubleshooting. Include the region, environment, and purpose in your names. Third, monitor your VPN gateway metrics. Set up alerts for connection state, bandwidth utilization, and packet drops. Azure Monitor provides excellent insights into gateway performance. Finally, document your network topology and keep it updated as you add more spokes. A visual diagram helps new team members understand the architecture quickly. Cost optimization strategies. Remote gateway configuration can significantly reduce your Azure networking costs, but there are additional optimization strategies to consider. First, right-size your VPN gateway SKU. Don't over-provision bandwidth you don't need. You can always scale up later if requirements change. Monitor actual throughput usage to make informed decisions. Second, consider using ExpressRoute instead of VPN for high bandwidth scenarios. While more expensive initially, ExpressRoute can be more cost-effective for consistent high-volume traffic. Third, review your data transfer costs. VNet peering has data transfer charges, especially for global VNet peering. Keep frequently communicating resources in the same region when possible. Finally, use Azure Cost Management to track your networking spend and set up budget alerts to prevent surprises. Security considerations. Security is paramount in any network architecture. Remote gateway configuration introduces specific security considerations that you must address. First, implement network security groups, or NSGs, at both the subnet and network interface levels. Don't rely solely on the VPN tunnel for security. Defense in depth is crucial. Second, use Azure Firewall or network virtual appliances in the hub VNet to inspect and filter traffic between spokes and on-premises. This creates a security choke point for all external traffic. Third, enable Azure Monitor and Network Watcher to log and monitor traffic flows. You need visibility into what's happening in your network to detect potential security issues. Finally, regularly review and audit your peering configurations. Ensure that only authorized VNets have access to your gateway resources. Scaling and future considerations. As your Azure environment grows, you'll need to consider how this architecture scales and what future changes might be needed. The hub and spoke model scales well horizontally. You can add many spoke VNets to a single hub. However, consider the VPN gateway's connection limits and bandwidth capacity as you scale. For very large environments, consider implementing multiple hubs in different regions with global VNet peering between them. This provides redundancy and reduces latency for geographically distributed workloads. Keep an eye on emerging Azure networking services. Features like Virtual WAN can simplify complex hub and spoke deployments and provide additional capabilities like SD-WAN integration. Finally, plan for hybrid scenarios where you might need both ExpressRoute and VPN connectivity. The architecture we've built today provides a solid foundation for these advanced scenarios. Thank you for joining this deep dive into Azure Vnet remote gateway configuration. You now have the knowledge and commands needed to implement this powerful networking pattern in your own environment.